So, a very good afternoon to all of you guys. Before starting today's lecture, I just want to brief that what we had discussed previously in this unit. So, this is the second unit in which we were discussing about the casting. Okay, until now, we have discussed the definition, the elements, basic terminology that what are the elements that we are using for a casting purpose that we have gone through. And after that, we discuss about the molding sand, that what is the kind of molding sand that means how to prepare that molding sand, what is the properties that is required. And we discussed along with that the allowances that is affiliated with the uh, casting or the patterns basically, because whenever like different types of the materials we are using for the casting purpose, at that time there is a different allowances that we have to provide, because shrinkage allowances is the main allowance which is affiliated with the material. Okay, so whenever we are going for a casting of the different materials, for that there is a different shrinkage allowances there, so that we have to keep in mind. Apart from that, also we have discussed the four different types of the casting. Okay, that is draping allowance. Sorry, not the allowances. Okay, that is the draft or taper. We have to distortion and camber and the wrapping allowances. After that, we discuss about the basic principles that we have to use in the last class. Okay, so in before that, okay, so in which basically two is the basic principle that we are keeping in mind, that is Bernoulli's theorem that we are applying, and second one is the continuity equation. Apart from that, also we have discussed about the Reynolds number that we are taking, because for the pipe flow, the laminar flow is generally considered. Okay, so Reynolds number should be less than 2000. Okay, and then we started the designing of the gating system. So designing of the gating system, that depends on that what are the elements that is we are using for the casting purpose. Means when we are casting, that time how many elements, how many what elements are coming in contact. So there is a pouring basin, sprue, a runner, gate, and in gate also, like we have discussed, like when we are filling the cavities through the top gate, bottom gate, parting gate, or the step gate that we had discussed in the last lecture. Okay, up to the last lecture. So today in this lecture number 6, we are going to discuss about the different types of the casting techniques. So I will just brief you about some of the casting techniques, not all the things, because as I mentioned in the previously that I'm just taking only the part which is important to you, because I'm not going into that much details because you are not mechanical engineering students. That's why. Okay. So I will. I have a PDF of very famous book in the mechanical engineering for this casting and manufacturing technology. We can say that is P and Rao. Okay. So I'm just taking the PDF of that, and I will just discuss the different types of the basic different types of the techniques that is available to us. Okay, and then we will discuss some of the casting defects. Not, I'm not saying all the casting defects, because there are number of casting defects are there, but what we can usually see from the neck dies. Okay, so that is generally that has been asked in many examinations. That's why. Fine. So, and that is important. So let's start. Okay. So here I'm taking, by the way, I will share this PDF to you. So these what is written in there, you can directly go through that. But I'm just discussing what are the figures that is we have. Okay, through which basically I can explain. I'm just explaining that what is the casting, what kind of casting is. So simply these first, that is we are going to discuss about the precision investment casting, or sometimes we call it as a investment casting. So in the means guys, what we are going to do in this basically, that in these casting processes is when as we have discussed in the uh, casting terminology, that first is there is a pouring basin, then there is a sprue, then material is coming to the runner, then there is a gate is there, and after the gate the metal is molten metal is flowing into the mold cavity. So now here that's basically the simple casting. Okay, or we can say like permanent mold casting, that is basically the named as a permanent mold casting. But here how we can fill, how we can basically make, how we can use the patterns. Okay, means what types of the patterns we can use, means what through there are different type of the techniques through which we can produce the patterns, and then we can mount it, and then we can fill the molten material into that mold cavity. So this is basically the process in all the casting. Okay, so this is the first casting that we are going to discuss, that is the investment casting. Okay, so step one is like this is basically the die. Okay, this like cross section is basically the die. Okay, inside die is nothing but like what types of the shape actually we need for the casting purpose. Okay, so for that we have to use a die. Okay, so here what we are doing is we are using this die, and this type of the die like this is the you can see that this is a hollow cylinder solid, this is a solid cylinder. Okay, and solid cylinder we have to cast basically here number of solid cylinder we have to cast. Okay, so this is, you can see that this is the diameter. Okay, and this is basically the length of that. Okay, so this is the solid cylinder. Okay, this is the solid cylinder we have to use. Okay, so here we are using the, in this investment casting basically the pattern is made up of the wax. The pattern is made up of the wax. Okay, so this wax is basically, wax is simply like what the material is, it's a kind of chemical we can say. Okay, or if I simply say that then candles we are using, okay, generally to lightning this. So this candle is made up of the wax. Okay, so that type of the material we are using, and what we are doing is we have the liquid material initially. Liquid material. Okay, because this is melted at very low temperature, so what we are doing is we are just filling the wax into the solid part of this wax into the container, and we are heating it. Then we are heating, and we are just filling it inside this through these hoses is available. So through these pipes, we can say hoses or pipes, we can say. So we are filling it, and once it will be filled, and then we are keeping it outside. Okay, so this is, we have kept it outside. So this is like, as I said, that number of cylinder we are producing here. So what we are doing is, like here, if you will see, then this is a kind of cluster assembly. We are calling it as a cluster assembly. So that cluster assembly means the number of components we are producing at the same time. Fine. So these like here you can see that six components is mounted on this cluster assembly at the same time. So what we are doing is we are making these type of the wax patterns one by one, like six pattern is done. Then what we are doing is we have this kind of assembly, so that it is this is basically the portion which is a, we can say like pouring basin. And okay, so this is, you can see that this is the pouring basin. Okay, and after that there is a sprue. This vertical portion is basically the sprue, and after that, that in the sides basically this is a gate is there. Okay, runner and the gate is there. So this, through this gate, at the entry of this gate basically, if you will see from that perspective, then this is a kind of up to this is a gate. Okay, and then it is in this side, it is a mold cavity. So what we are doing is this is the runner, which is a horizontal portion. So here directly, because runner is just like to flow the material. Okay, so here we are not using the runner, but on behalf of using this runner, we are just directly using this cavity, which is like this one. Okay, like this. Okay, so like this you can assume. Okay, so this is here we are keeping one of the wax pattern, another will be here because this is the exit, and another will be here. Okay, and another, if you want to keep it over here, you can keep. So this is actually in this, if you will see this figure, then there is three in this side. Okay, this is basically this sprue, we can say. So or at this portion we are connecting this gate, so this gate is connected with this pattern. Here also we are using, means in this direction three, and in this direction three, so total six patterns we are attaching at the same times on this assembly. Okay, now after this in this container basically we are using the we are using basically, you can say, like liquid materials, okay, or the bentonitic solution, we can say. Once binder, we can say, like here binders we are using like sodium silicate or ethyl silicate, you can say. Okay, so these binders we are using, and what we are doing is we are now it is fixed. These patterns is basically fixed on the gate or this assembly. Now we are dipping this assembly inside this solution or binder, we can say. Okay, so once you will dip it inside, okay, once you will dip it inside, or like you can also say, like here we are using the slurry. Okay, this slurry. Okay, so this slurry is nothing but like binder, we can say that binders are there. Slurry means the semi-solid kind of materials, means liquid material is also there, and the solid material, solid particles is also there. So binders we are using, plus we can say like ceramic materials, ceramic metals we are using, ceramic solids, we can say, or ceramic materials, we can say. Means it's a kind of like a very small in size. Okay, so that we are mixing with the binders, and initially we are keeping this slurry into this container, and we are dipping it inside. Okay, so we are keeping it this assembly inside for the some time, so that this coat, this whatever, like for an example, this is the pattern. Okay, so this is the pattern. Then if I will dip it inside, then what will happen, that this binders will stick to the surface. Okay, now when it will stick to the surface, is we are using the ceramic solid or the ceramic metal, this when you will see the surface which is layered, which is basically the coated over this wax, it will be like the surface roughness is high. Okay, and if you will see, simply compare, like हमारे जब houses में जब plaster होता है, so if we are that first there is a brick, we are just constructing a wall, and then we are just going for a plastering. Okay, so plaster होता है, then if you will see the surface roughness, this is little bit, मतलब ज़्यादा surface roughness होती है. Over that, what we are doing is we are going for a POP. Okay, so here we are using the refractory materials or silica sand, we can say. Okay, this is SiC silica sands we are using. So this silica sand is again like this is, here we are just using the silica sand only, so that whatever the coating is there, and there is the surface roughness is high, which is over coating over this surface, wax surface. So it will when you will dip inside this silica sand particles or the refractory materials, it will become little bit uniform. Okay, uniform, and the surface roughness will be a little bit much better than what we are getting in this one. Okay, so this step, whatever the we are going for this one here, silica and we are lapping over the surface, okay, by dipping inside. So we are calling it this process as a stuccoid. Okay, and so this is basically the process. Okay, this is just a terminology that we are using in phase. Okay, so this is stuccoing we are doing. Okay, this is a stuccoing process. So we are dipping it inside, and over the reflect over that pattern, basically we are lapping up we are just from top view, basically top over that, first we are keeping inside, and then we are dipping the we are putting the, like we can say, we are filling these refractive materials over that. Okay, so A is like this is the binders as there. Okay, so binders is already there, so it will be like still that is in the liquid form. So when you will fill the silica sand over that, that will attach over the surface of this coating. Okay, so that will make the smooth coating. Okay, so now what we are doing is, after that we are just rotating this one, like again we are bringing in this, like if you will see that this pouring basin is at the top position. Now we are again keeping it over the, this is the pouring basin now. Okay, so this black color, this is, if you will see this one, then this black color is basically inside the wax pattern. Okay, so what we are doing is, after once this silica sand is left over the pattern, okay, we are heating it, means it will become like, we are keeping it for the drying purpose, and after once it will be dry, we are just heating it. So when you will heat, now what will happen is, we light the candle. Okay, as we light the candle material, which is a wax, it start basically vaporizing. Okay, or it will start melting. So for the heating, it's not like we are supplying the arc. Okay, heating is like just for the low temperature we are maintaining it. So whatever, and we are keeping it like just opposite to the direction. Okay, so whatever the molten material, not sorry, not molten material, whatever the wax material, because when you will heat it, Okay, you will provide the heat, means temperature rises. So because of the rise in temperature, this wax will be become melt. Okay, this wax will become melt, and that will be taken it out. Okay, means the same material which you were using for the pattern, through which you prepared the pattern initially, this one. So now this material is available in the liquid form here. Okay, so again, this can be collected over here, this in the container, and you can again use for the making of the patterns. Fine. So now, once this inside this material is wax pattern has been removed, now this wax is removed. So if you will see this one, then it will become a hollow part now. Okay, because now this completely this become because now over that basically the lap is there, and that boundary is completely covered. So now it will become inside it will become hollow from inside. Okay, so now rotate it and just keep it inside the container, and just fill the mold cavity. Just fill the molten material. So when you will fill the molten material, it will be, as these are the hollow parts, so this will be move inside, this will cover the mold cavity. Okay, now this is a cavity only because this is a hollow part. So once it will be like uh, filled. Okay, for the time being we are just keeping like that, and after some times when it will become completely solidified, we are just keeping it outside, and finally the casting is ready. Okay, means whatever the things initially we were keeping preparing this pattern of the solid cylinder we have to produce. So same kind of the casting that can we will get it from here. Okay, so if we have to produce the number of components at the same times, then we can use this investment casting. Okay, by the way, there is another casting process which is the advanced casting process, that is the evaporative pattern casting. That is also a similar kind of evaporative evaporative pattern casting. This is that evaporative pattern casting is also same kind of pattern, but there whatever the patterns that we are using, that will be evaporated once the molten material come in contact with that pattern. Okay, so that is a little bit different, and that is the advanced casting process. So that is I'm not discussing that one, but this is basically the investment casting. Okay, and this is complete. This is all the things is written in this whatever the PDF that okay, these lines are there. Okay, para is there. So. This is basically I'm just briefing you that what does these casting and how we can do. Okay, let's move to the next one. So please guys, you should go through the whatever the advantage and disadvantage and theory part is there. By the way, theory that I have discussed, that is only written there. Okay, so you can just see once, at least once. Okay, now the application is important, that if we are using the investment casting, then jewelry, surgical instruments, that can be prepared previously, but nowadays the vanes and the blades of the gas turbine can be produced. Okay, apart from that, shuttle eye, the space shuttle eye, that for the uh, that also producing through this investment casting. Okay, okay, let's move to the next one, which is a die casting. Okay, so if we'll see this die casting. Okay, so die casting, as the name suggests, that we are using the die. Okay, inside only we are using we are filling the molten material, and casting is ready. So for this one, basically we are not preparing a separate pattern, but we are preparing the die as per the requirement. Okay, so here for an example, if you will see, then this kind of pattern we have to produce, this kind of pattern that we have to produce. Okay, so what we are doing is, what first of all I'm just briefing that what these elements are, so that would be easy for you. Okay, so if you will see, then there are two dies. Here is a partition. Okay, so in this side, this is a stationary half of the die, and this is a moving half. Moving half means it's kind of like this. So this is a stationary through which the molten material is coming. Okay, we are inserting inside, and this is basically the movable die. Okay, so this is a stationary half, and this is a movable half. Along with this die, this is basically the ejector plate, so that we are just ejecting the we are just moving this die through that one. Okay, and these are basically the ejector pins, these three, one, two, and the three. Okay, so these three, one, two, and the three, these are the ejector pins. Apart from this, if you will see here, basically we are keeping some hollow sections, these kind of hollow sections we are creating. So when this hollow section is created, we are keeping the gas vent there. So whatever the gas entrapment is there during this casting process, that will be taking it out from the gas vent or air vent, we can say. Okay, so there will be no entrapment. So if you will see, this is basically the structure of the movable die or movable half, we can say. Here we are using these four because this is basically a circular section, okay, or sometimes it is a rectangular sections. So these hollow sections we are using, these hollow sections is just to provide the water supply, because dye is also like a kind of material only that is made up. Okay, so if we are if we want to use it for the more time, means the life of that we have to increase, then we have to use the cooling material as well. So by the way, we are using the cooling water only, means cooling for the water only we are using for the cooling purpose. But we are using it, okay, these holes we are using to cool it down, okay, so that temperature that will not rise that much, okay. So and also the certification should be time done within time limit, okay. So this is the fixed pin, okay. So here we are just providing this to hold this fixed die. And this we can say like here we are using the gate, so this is a runner, okay. Runner is just like a horizontal passage only, whether it's a horizontal or vertical, but it's a flat section only, okay, that we had already discussed in the design of that. Now what how it is working actually, again if you will see, then this die casting, then we have divided that into the high pressure and the low pressure casting, okay. Means the hot chamber and the cold chamber casting. So this is a kind of cold chamber, okay. So how it is a cold chamber, and then I will explain you later, and later as well, after this one. So here what we are doing is yeah, this is basically the cylinder, okay. This is cylinder we are using, okay. And we are using this as a plunger or piston, we can say, okay, piston we can say. So what we are doing is we are just keeping this piston outside first, okay. We are just keeping it outside, and we are filling the molten material into that. By the way, actually somewhere also here we are keeping the hole, so that through the ladle basically we are filling the molten material into that, into this cylinder, okay. So this cylinder is filled with the liquid material, okay. This is black one, you can see that this is a liquid material, okay. And then what we are doing is we are just pushing it inside the plunger, okay. So when we are pushing it, whatever the material is there, guys, here we are not keeping any such kind of leakage, okay. Please do not consider that one. So we are keeping we are pushing this piston into this side. So when we are pushing, it will move inside, okay. This will move inside, okay. So here this is the top mark, or the here the close section of the cylinder, and in this side it's hollow, this runner side, okay. So this molten material will move in this direction, and whatever the cavity that we have prepared inside this die that will be filled as per the requirement, okay. So also here like some of apart from this, if you will see that this is only the shape that we have to create, but still if you will see the top view, when you will see this section, this is a kind of we are just providing this one, so that some extra amount of the material should be filled. Why extra amount? Because there will be no because it happens that when you will fill the molten material, as it will cool very fastly. So whatever as you are applying the pressure, so that it should be distributed equally, okay. It should be distributed equally, so that that's why we are keeping these type of guts, okay. We are calling it as a guts or guts, okay. So gutters also we are saying sometimes. So that what exactly the meaning is gutters, that some extra amount of, or whatever the vestige material is there, we are just keeping. But here the guts meaning is not like vestige material, it's a kind of like just to fulfill whatever the die or the mold we are using, mold cavity we have to fill. If whatever the extra amount will be there, that will be leakage through these guts, so we can get an idea that now it has been filled, okay. Now here the important thing is we have to keep in mind that whatever the volume of this cylinder, okay, this should be greater than the whatever the volume of the molten material that is required for the mold cavity. Please keep in mind this one, because if we will not, if this volume will not be, means whatever the amount of the molten material that we are filling inside this mold, this cylinder, okay, if it is not greater than, if this volume is not greater than the volume of the casting, or the casting that we have to do, then what will happen, that it will fuse in between only, means you will fill up to this one, but this much portion will be remaining, still remaining. Okay, so what we have to keep in mind that whatever the volume of the casting that we have to fill, that volume of the cylinder that should be greater than that one. Okay, please keep in mind this one. So there is a okay, so this is there is a two types of the casting in this die casting only, that hot chamber and the cold chamber. So cold chamber is like what we have discussed. Okay, if you will see the figure, this figure. Okay, this is the figure for this. Okay, so this is the for the cold chamber, that we are just using this ladle over here and we are filling the material. This is basically the core. Okay, and here we have to produce this type of the casting. Okay, so what we are doing is we are filling the molten material through the ladle and we are just pushing it. As you will push whatever the molten material, this black one that we have the kept inside, filled inside this cylinder, that will push it inside the cavity. Okay, so once it will be filled, we are just moving this movable die in this direction, backside. Okay, and this casting is prepared, and here we are using a kind of piston or ejecting pin, we can say. By the way, if you will see in this figure, this is a fixed pin, and sometimes ejecting pin we are using. So ejecting pin is less like that, is once it will be connected with this one, so we are just pushing it inside, so it will just push it. So that will be taking it out from the movable die. Okay, so this is basically the process of the cold chamber. Now in the hot chamber die casting, what we are doing is we are just using the hot chamber only. Hot chamber means whatever the you can say like in cold chamber, what we are doing is we are keeping the molten material into the ladle. We are filling first the molten material into the ladle. From the furnace we are filling into the ladle, and then late to the ladle we are filling uh, into the piston, we can say cylinder, sorry, cylinder. Okay, so here what we are doing is we are just keeping this okay, here if you will see, then this is basically this hollow section, this white color section is basically the pipe only, this hollow section. Okay, so in which here we have provided the this is basically the furnace also, this is a holding furnace. Okay, in which you are melting the material, and through some mechanism we are just pumping it inside this liquid material, we are just pumping it. Okay, this molten material we are pumping it inside, and once some amount of the material, some volume of the material, molten material is filled up to this. Okay, then what we are doing is we are just pushing it inside. So this is basically the gooseneck, some kind of plunger we are using. Okay, this is the assembly, electric assembly or the pump assembly, hydraulic assembly, we can say. So we are just pushing it inside through this cylinder piston mechanism. So this material, when it will piston will come in this direction, this material is there, so it will be push it out, and this will be move inside this one. Okay, so this is basically the this hollow, this red color here. So this is basically a kind of casting we are preparing. So this is the pattern that is left between the movable die and the this is the movable and the fixed die. So we are filling it inside, and once whatever the volume is there, that will be filled. Okay, then we are just keeping it inside, and for again this material will be filled. So now this liquid material, because entry is already provided, so it will fill inside. But what will happen that during the solidification it will take some time. Okay, so we cannot like once this is pushed, you have pushed it inside, then liquid material is fixed inside, so that immediately you can this move uh, uh, the movable die. It's not like that, we cannot do like that. Okay, so we will keeping for some time. Still that also whatever the material that has been filled inside this one, we also want that that should be liquid only. Okay, otherwise that material has been filled, so it will become solid after some time. So we want that should be liquid, in the liquid form only, till it will solidify. Okay, so once it will be solidified, we are taking it out and we are just making bring out the casting, and again we are making this die, complete die. And whatever the liquid material is there, now it should become solid. But it should not become solid. Why? Because we are using the holding furnace, or means heating furnace we are using, hot chamber we are using. Okay, so that is maintaining that liquid temperature. So again the liquid is already filled, we are just pushing it inside, and that is again the next casting is ready. So this is the hot chamber casting. Fine. So die casting means whatever the shape that we have to create, that is we are creating inside the two dies. Okay, first is the fixed die and another is the movable die. Okay, so that is Okay, so here you can see that this is basically the furnace, the same figure, like this is the furnace we are keeping. Okay, and this is a plunger assembly. Okay, this plunger means piston, cylinder piston. So this liquid black color is the material that we are pushing it inside, and once it will be filled, we are just taking it out. Okay, once it will be solidified, we are just taking it out. Okay, and then this is basically the ejecting pin. So it will just apply the pressure on that, so that will be come out, and we are just taking it out again. We are keeping this one in this first stage. Okay, so it's like that only, repetition. Okay, fine. Next is the centrifugal casting. Okay, so this centrifugal casting is generally if we have to produce the hollow cylinders, okay, that time only we are using this casting. Just give me a break. Okay, so centrifugal casting is like if we have to produce the if we have to if we have to produce the hollow castings. Okay, hollow casting is like generally uh, okay, let's see there are three types of the casting. Okay, so first is a true casting. True centrifugal casting means sometimes also we call it simply like a centrifugal casting only. Okay, then there's the semi centrifugal casting and the centrifuging casting. Okay, so the definition is very simple, that if we have to produce the hollow pipes, okay, or hollow kind of the shapes which is symmetric to the centroidal axis, if we have to produce that one, then we can use the centrifugal casting. Okay, so if we talk about the true casting, true centrifugal casting, then just like if we I have to produce this structure. Okay, for an example, just try to assume that this is kind of whatever the cross section that is here. Okay, that is circular. Okay, so and hollow pipe. Okay, it has some thickness, this pan has some thickness. So if I have to produce this type of the pan of some specific length, then what I'm using is I am using a pattern of hollow section. Okay, and what we are doing is we are just filling this molten material into that. Okay, so when I will fill this molten material, for an example, this is a kind of ladle. It's a kind of ladle. This red color, just try to assume that liquid. It's a molten material. So this is a hollow section. This is a hollow pipe is there. So when we are filling it, okay, just when we are filling this molten material through the ladle, so when you will fill this molten material inside, where it will go, it will first fill the bottom part. Okay, so bottom part of this it will start filling. So now at that time, once this material start filling inside, what we are doing is we are just trying to rotate it, and it's not rotating, like it's not at a low rpm, at very high rpm we are producing. So it's like that one. Okay, it's like that. Okay, so like that one. So like that, what will happen, whatever the molten material that will come, that will try to push towards the periphery, towards the outside periphery. Okay, towards the outside periphery means inside the circular, whatever the maximum diameter is there, inside diameter, up to that, that will flow. Okay, and that will flow not only in some specific area, throughout this length it will flow. Okay, so accordingly, whatever the length of the pipe or diameter, length of the pipe that we have to produce, we are using the pattern of that pipes, and we are trying to rotate it when you will fill. So it's like when you will add continuously the material into that. Okay, so first it will fill some specific kind of thickness, and then this thickness is increases from the outside periphery. Okay, so it's like we are using the cooling assemblies as well, like cooling water also, we are providing for the cooling purpose, so that solidification should start fast. Okay, and by the way, every time the solidification starts from the boundaries only, and whatever initially the material that we are filling, that is in coming in contact with the boundaries only, and you are rotating, so the solidification will be fast. So as you have to rotate, and as you will just as you will whatever the thickness that has been gained, after that you can just close the liquid or the molten material from this one, the ladle that you are using. Okay, you just close that supply, and till still you should start rotating this one, so that till it will become completely solidified, means it will become solidified from both the sides, from the inside boundaries as well as from the outside boundaries. It starts solidification. That time you can for the time being, you can reduce the speed, or you can just stop it for the some time. Okay, now here the question is two questions can be raised, that is we are rotating this one. So what will happen that if generally most of the time, 99% of the time, we are not casting the 100% pure material, okay, or pure metals. So what it will happen that it will be like uh, alloy, yeah, different types of the alloy only, because if we talk about simply the iron as well, so it's not a completely iron. Some kind of some amount of silicon is there, sulfur is there, phosphorus is there, manganese is there, okay. So these are just a kind of, it is a alloy, okay. So what will happen that whatever the high density is there, that will, when you will rotate it, that high density particle should move towards the outside boundary, and whatever the low density particle will be there, that will be towards the center, okay. I mean, if you will see that this is the final product, then over this is a specific thickness is there. So if this is a specific thickness, let me take- so if you will see this one, that this is the hollow casting, just try to assume that this section is basically hollow, and this is the thickness that we have achieved. So if you will see the particle, the metals which is surrounded by this one, it is a high density metals, and whatever the metals that is coming inside this, over this periphery, okay, throughout the length, that should be of a low density. So uh, this will be always be there. This type of the uh, varying density particles will be there, okay. This you cannot change it, okay. Another is like what I want to discuss is, okay, that is cooling, that I have already discussed, okay. Okay, then this is the thing, cooling, as I have already discussed, and this is the outside density differences. So this is basically, we call it as a true centrifugal casting. Fine. Next is the semi-centrifugal casting. So for an example, like if you will see the wind turbine, okay, so not wind turbine, the wind tunnel, okay, means if you will see the fan that we are using in the wind, okay, that has 3 to 4 wings, okay, and there is a propeller inside, okay. So this propeller, it's not like a fan, okay. In ceiling fan, what will happen that the hollow this motor section is different, and then when we are purchasing from the market, this motor section is separated and these wings are separated. So what we are doing is we are just fixing these wings through the nut and bolts, okay. But in the wind turbine assembly, this is the propeller is casted. This is basically the casted, these fans and this wings along with this propeller is casted. So here we are using the semi-centrifugal casting, okay. So this is a kind of it's from 2D only, it is looking like a front view, but when you will see from the top view, it is like top view, it is like the sections, okay. This is the sections which is attached with this one, okay. So this is a this black one is basically the molten material only. So here what we are doing is, this is a kind of container we are using, or cope and drag we can say, okay, which is mounted over the table, okay. This is the fixture, and we are rotating this over, the fixture is mounted over a rotating pad, okay. So we are just rotating this one, and from the top view we are filling the molten material. So this type of the, like, this is the sand here, this is basically the sand we are molding, sand we are using, okay. And then this first we are creating this type of the pattern inside this, and then we are just filling the molten material. So while filling the molten material also, we are rotating this one. So please keep in mind, that's why we are calling it as a centrifugal and semi centrifugal, because this type of the shape that we are producing, this type of the shape is, you can say, like it's not constant, the whatever the cross sectional area is not constant throughout the length. It's not like a yeah, it's not like a constant cross sectional area, whatever we can see from the inside, from the front view, that is not constant throughout the length, but it is varying. That's why we are calling it as a semi centrifugal, okay. So this is the semi centrifugal. Next is the centrifuging casting, okay. This is nothing but like if we have to produce like like for an example, if we have to produce the hollow cylinders, okay, then hollow cylinder should be like it has a hollow some kind of thickness, okay, of a different radius we can say, or specific length, okay. So this is basically, if you will see the front view, then this is a specific length, okay, that is that has some thickness, okay. This black color is basically the thickness we can say, and that is surrounded outside, that is surrounded the molding sand only, okay. So or core we can say, this is a core, okay. So now number of assemblies from top view, when you will see, then this is basically the core sand we are using, okay. This is the core sand, and from here basically we are filling the molten materials. When you will fill the molten material, this molten material will flow through these channels, or these channels is nothing but the runner and the gate only, and it will flow in this direction. I'm just using for the red color for this, okay. So this will fill in this areas, okay, and it has some length, because you can see here this is the length. So this will be filled throughout this hollow cylinder, okay. And also, like here also, why we are calling it as a centrifuging, or it is a part of centrifugal, because the fixture over it is over this is mounted, this is basically revolving table, so this is also rotating. So when we are filling the molten material, okay, this will rotate, okay. So this will rotate, so it will reach the molten material should reach to the mold cavity, okay. So that's why we are calling it as a centrifuging casting, okay. So this is a type of the centrifugal casting, okay. Now there are two more casting that I'm going to discuss, very that is also very easy. That is the squeeze casting. First is the squeeze casting. So here is whatever the shape that we have to produce. For example, if I have to produce this glass, okay, for an example, if I have to produce this glass, then whatever the thickness is there, so what in die casting, what we are taking, that die inside area we are creating like that, okay. The sections, whatever the casting that we have to produce, accordingly the same replica of that we are creating inside the die. In this squeeze casting, if I have to produce this glass, then what I'm doing is, first of all, I'm just making die we can say, okay. So die is like whatever the outside diameter is there, outside, this is the outside diameter, so accordingly this circular section I'm using the die, okay. This will be flayed from the bottom view, and there's some curve is there, and some kind of these sections are there. So that is also why I'm creating outside this some kind of cup we can say, or die we can say, I'm using, okay. Another thing is, that should be hollow. It's not like that die I have prepared, so inside will fill the material, so that that will become solid, okay. But here it's hollow, okay. So whatever the thickness is there, okay, whatever the thickness is there, that has been reduced, and whatever the hollow section is there, means initially it is large, this cross sectional area, if you will see, then this is large, and with respect to the length it is decreasing, up to here it is decreasing, and then it is constant, okay. So accordingly, this type of the plunger I am creating, okay, means a plunger we are making, okay. So what we are doing is, we are filling the molten material into the die, and then we are pushing the plunger into that. So whatever the material, excessive amount of material is there, liquid molten material, that will be come out, okay. Or we will collect it into the container, okay. So that will be collected out. So after, for the time being, we are just keeping like that, and after that we are just pulling it. So if you will see, okay, if you will see, then this is a die, okay, and this is a punch, so we'll punch it inside, okay. And this is basically the furnace, and this black color is basically the liquid molten material. So this is the step two, we are filling this molten material into the die. So also one more thing, as I said, that if excessive amount of the molten material will be there, so that will be bring it out. So why like, it's not like I will produce the glass only one piece, I will produce the thousands of pieces or lakhs of the pieces at the same time. So in one process I will just get to know that how much amount of the material is needed, okay. So accordingly I will fill into that. So here the same process is applied, okay. So this is filled up to this only, not up to this, okay. So we have to keep in mind this one, that will save our time as well as cost money. So we are just filling it half, and then once it will be filled, now we are pushing this plunger inside, okay, or the punch inside. So this shape is created, we are keeping this shape till the solidification. Once the solidification is done, we are just pushing again, bringing it out, okay, this plunger or the punch we can say. So whatever the shape is there, that will be like attached along with this uh, uh, punch. Or also, like if we are not pushing it outside, then we are using this another plunger on the bottom side, so that will basically push it, Okay, that will basically push it. Okay, and now we are just taking it out. Now there is a possibility that this molten material should stick to the plunger, so that we are keeping the solid lubrication like graphite, we can say. So we are keeping this solidification lubrication over this die as well as over this punch area. Okay, which is coming in contact with the molten material, so that once this molten material could be solidified, that will be easily removed. Okay, this is the switch casting. It's easy. Okay, so next is the slush casting. This slush casting is generally people not use it, or many industry will not use it. The reason is very simple. First let me explain. So this is basically the cope and drag, we can say, like, okay, and here we have filled the molding sand, we can say, and whatever the shape that we have to create. Okay, suppose this type of the shape that we have to create, this black color hollow shape, we can say this is the hollow portion. Okay, so what we are doing is we are just creating that one, means through the hands or through the chisels, we are just making this shape, and we are just removing the molding sand from this area. Okay, so this boundary is visible to you. Okay, so this inside this, the hollow, this molding sand was there initially, now we have removed that one. Okay, then what we are doing is we have the molten material, so we are filling this molten material into that. Okay, so when this is complete, this molten material is completely filled, this black color is this is completely filled. Now there's a property of the solidification, that always the solidification is start from the boundaries. Okay, solidification always start from the boundaries. Okay, boundaries means from this side. Okay, because here there is a moisture is there, so moisture means the liquid amount is there. Okay, water content is there. So first that will basically, the low temperature come in contact with that boundaries only. Okay, and that has the capacity, like we have already discussed, the green strength, dry strength, and the hot strength that we have discussed. So that has the properties to withstand, this molding sand has the properties to withstand whatever the molten material that we are depositing inside. So what will happen, as the solidification starts from the boundaries, like whatever the thickness is needed. For an example, we have to, first of all, we have to calculate before the casting, that how, if this molten material is taking from here only, it will start from the, because if you will see this in this one, then from here, from this boundary only, it will start a solidification. Okay, so how much thickness is, like this much thickness, for example this is 2 mm thickness, and it takes around 2 minutes. For an example, it takes around 2 minutes to solidify 2 mm thickness, then only it will move towards this side. Okay, towards the center. So if 2 minutes is done, once we have filled the we have filled this molten material into that. Okay, in the step 2 we have filled this molten material, and once the 2 minutes is done, after that we are just reciprocating it. So what will happen, we are whatever the molten material, liquid material is there, because this material 2 mm is already solidified, right? Because 2 mm is 2 minutes is done. So 2 minutes is done, 2 mm is already solidified. Whatever the liquid material is there, that will be taken it out. So again we are using a container or the furnace in which the liquid material is taken it out, and we are just keeping it for some time. Okay, and then this cope and drag part is removed, so that we will get a final cavity. Okay, so this is how we are we can say like it's a heat and trial method. Okay, so we are filling the molten material, and then for some time we are keeping, so that the solidification should start from the boundaries. So it will, whatever the time it will take, accordingly we are keeping, and then we are removing the liquid materials from that. Okay, so these are the basic castings that I have to discuss with you. Okay, now just give me 1 minute break. After that I'm going to discuss these casting defects. Okay. Okay, guys. So casting defects. So there are, basically there are a number of casting defects are there, but these are just few which is important. Okay. So first is the slag and inclusions. By the way, there is no figure in the slag and inclusion. That's why I'm discussing first this one. So slag and inclusions. Basically, this is it will be very clear when we will discuss about the welding part. But just for the being time being, just try to assume that we are using the flux. Okay, we are using whenever like we are melting, as we are keeping some solid material into the furnace. Okay, and we are heating it. So when we are heating, is everything is done in the atmosphere only. We cannot go for the vacuum we cannot go in the vacuum. So we are doing at the atmosphere. So whatever the atmospheric gases are there, oxygen is there. So there is a possibility that whatever the gases or the fumes that is coming out from the or the material, liquid material which is there in the furnace, when it will make reaction with the oxygens, O2 that is present in the atmosphere, so that will form the oxides, okay, or inclusions we can say. So for that, basically it should not be formed like Al2O3, okay. So it should not be formed. So for that only, what we are doing is, because otherwise if the oxide formation is there, then it will weaken, or it will reduces the strength of the casting, okay. And by the way, all the casting defects only, that will reduces the strength only, okay. So that will basically reduce the strength of the casting. So what we are doing is, we are using the flux into that, okay. So that is kind of we can say like that will prevent the formation of the oxides, okay. So what will happen that like for an example, this is a pouring basin, and here we are using the ladle. So when we are filling the molten material into that, so when we are filling the molten material through the ladle, means liquid material through the ladles, we have to keep in mind that we have to use some kind of filter over here, okay. And also, like if you will see the geometry of this pouring basin, when you are filling this molten material, and so what will happen that whatever the flux, because flux will not melt, okay, that is a kind of refractory materials, okay. So that will not be melt. So what will happen, when you will see when you will fill the pouring basin, when it will fill up to this one, these impurities will be uh, floated over the surface. So what will happen at that time, we can take it out, not by the hand but the filters, okay. So the filters we are using, so that these flux will be taken it out. So what will happen, by adding the flux into the furnace, that will prevent the formation of the oxide. So that will be helpful for us, okay. And if this flux should not become a part of this casting, so that here we are using these just we are just taking it out, okay. So this is basically the, means if we'll not use the flux, then there will be a formation of the slag inclusions. So for that also we are using this flux, okay. So please keep in mind. So this is a slag, why there is a formation, when this oxide will become in contact with this molten material, they will form the cavities, okay. Next is the blow holes and the open holes. Open holes is like it's again like okay, that's, it's again like is we are using the molding sand, okay, in which the molten material is filled. So is this moisture is there in the molding sand, there is a moisture is there. Moisture means the water content is there. So water content is like when you will heat up the water suddenly at a very high temperature, okay, because water will become steam at 100-degree only, okay. But when a high amount of the temperature will come in contact with this one, definitely the temperature of this moisture or the molding sand is increases. So it will become dry. But when the where this moisture is gone, this moisture is, there's a possibility that this water content will be vaporized, or it will become a steam. And if this will become steam, there is a possibility to there's a formation of the bubbles, okay, bubbles, okay. If this bubbles is formed over the surface, like this is below this casting is there, and if this bubbles is formed over the surface of this, okay, then we call it as a open holes. And if this formation, if these bubbles is formed inside the casting, then we call it as a blowholes, okay. So this is a blowholes, and this is the blowholes, like this is a shading is like this is not completely dark, but little bit shade in color. So inside this one, okay, and this is the dark in shade. So this is the over the surface, okay. So this is the open holes, okay. Now if you will see okay, this is the blowholes and the open holes. Now, as I, from the day when we are discussing that when this molten material we are filling, that there's a possibility of the gas entrapment, and because of that only we are designing all the things. But still there is a possibility that for that only we are using the gas vents. But still, if the gas will become a part of the casting, that will also form a kind of bubble only. But this bubble is not of steam, this is of gas or air, we can say, okay. So if this is of gas or air, we call it as a porosity. The defect name is changed, okay. If this is formed due to the formation, due to the moisture, or moisture into the steam, then we call it as a blowholes or the open holes. But if it is formed due to the entrapment of the porosity, sorry, gas or the air, we call it as a porosity. Okay. Next is the misrun and the cold shut. Misrun and the cold shut. Okay. So this will be very clear from this one. So this is the mold cavity. Okay, this is the mold cavity that we have to fill. Okay, so this we have to fill. So is we are using the sprue, and over that sprue basically we are using the pouring basin. Okay, so this pouring basin through which the molten material is coming. So this brown color molten material is coming, and through the ingate it is passes. Now as it is passes, so it will fill. Okay, so but what will happen that if we are using a very long length, okay, very long length, then what will happen that obviously this start filling this cross sectional areas. So what will happen that up to some specific length only it will be fused, this will become complete solidified, means after that it cannot move. Okay, so whatever the cross sectional area that is remaining inside this one, that can be filled, but after that it will not move. It this material has been fused or that becomes solid up to this. So what will happen, this much amount of the material will be remaining, still remaining, means it is not completely casted. Okay, it will not be completely casted. So this defect we call it as a misrun. Okay. Next is the cold shut. Okay, so cold shut is like if we are creating like this type of the geometry, means this type of like we are creating like uh, hollow ring we have to create. Okay, so if we are using filling this hollow ring like this, then this is a kind of sprue which is connected with, means sprue, then skim bob, and over that is connected with the pouring basin, so that we are filling the molten material, and this is a kind of runner we are using. Okay, so through these runners the molten material is passes, and through the ingot it is coming. So through both the sides we are filling this molten cavity, mold cavity. Okay, so what will happen is it is we are filling it inside, and this through this material is coming, through this side this material is coming. So it's like if you will see here, if you will see here and here, then in this area, in these areas this white color is mentioned, this white color will be there. So white color means that whatever the molten material that is coming from the bottom side and molten material which is coming from the top side, now that become semi solid. Okay, some liquid will come, then definitely it will mix up. But when the semi-solid will come, it will be like this one. Okay, so the some kind of deformation will always be there. Okay, so we call these defects as a cold shuts. Okay, so when we are using the two fumes or the two steams, two metal steams we are using, and they fuse before they do not fuse together, means before that only they fuse means they solidified. Okay, before coming in contact only they solidified, so we call this defects as the cold shut. Fine. So these are the just some of the defects and some of the casting processes which is necessary to discuss with you guys. So in this lecture we are stopping up to here, and in the next lecture we are starting the next unit, which is the not the welding. Welding will start later on, but we are starting the metal cutting operations. Okay, so thank you so much guys.